Welcome FRBS students. Today we are going to discuss about convolution theorem. Convolution theorem. Convolution of theorem. Statement. If Laplace inverse of Fs is equal to Ft and Laplace inverse of Gs is equal to Gt, then Laplace inverse of Fs into Gs is equal to 0 to t fu g of t minus u du is equal to f star g. Note, we denote zero to t fu g of t minus u du is equal to f star g and call convolution of f and d. F and g. Evaluation of inverse Laplace transform by using convolution theorem. Example. Prove that f star g is equal to g star e. Solution. That is, convolution is commutative. We have f star g is equal to 0 to t f of u g of t minus u du. Put t minus u is equal to phi. Implies t minus v is equal to u. Therefore, dt du is equal to tp. T is constant. Therefore, limits are also changed. Limits of u, limits of v. If u is equal to 0, then v is equal to t. If u is equal to t, therefore v is equal to 0. Therefore, f star g is equal to integration from t to 0, here minus v, derivative of t is 0, derivative of minus v is minus dv. F of u, that is t minus v, g of v, and du is equal to minus dv. Reverse the order of limits and absorb the negative sign. 0 to t, f of t minus v gv dv, that is 0 to t gv f of t minus v dv is equal to g star f. F star g is equal to g star f. Therefore, convolution of f and g is commutative. Example, use a convolution theorem to find first Laplace inverse of 1 upon s plus 3 into s minus 1. Second, Laplace inverse of 1 upon s minus 2 bracket square into s minus 2, s plus 2 bracket square into s minus 2. First example, solution. First example, Laplace inverse of 1 upon s plus 3 s minus 1. Therefore, Fs is equal to 1 upon s plus 3, Gs is equal to 1 upon s minus 1. Therefore, taking inverse Laplace transform on both sides, Laplace inverse of Fs is equal to Laplace inverse of 1 upon s plus 3. We know that Laplace inverse of 1 upon s plus k, that is e raised to minus kt. Here 3, therefore e raised to minus 3t, that is function of t. and Laplace inverse of gs is equal to Laplace inverse of 1 upon s minus 1 is equal to e raised to t, that is gt. 2 minutes. Sorry for interruption. Therefore, Laplace inverse of Fs into Gs is equal to 0 to t Ft f of u Ft g of t minus u fu g of t minus u du is equal to 0 to t ft is e raised to minus 3t, that is here fu, that is e raised to minus 3u, g of t minus u, here gt is e raised to minus e raised to t, therefore e raised to t minus u du is equal to 0 to t, here e raised to minus 3u, here e raised to minus u, e raised to minus 4u and e raised to t du. E raised to t is constant with respect to u, therefore take out say the integration e raised to t integration 0 to t e raised to minus 4u du. E raised to t integration of this e raised to minus 4u upon minus 4, 0 to t is equal to e raised to t e raised to minus 4t upon minus 4. Here for the lower limit it becomes plus, minus minus becomes plus, e raised to 0 upon 4 is equal to e raised to t, here e raised to 0 is 1 by 4 minus e raised to minus 4t upon 4 is equal to e raised to t minus e raised to 5t upon 4. Denominator is same. Next, Laplace inverse of second example 1 upon s plus 2 bracket square s minus 2. Therefore, fs is equal to 1 upon s plus 2 bracket square and gs is equal to 1 upon s minus 2. Therefore, taking Laplace inverse on both sides, Laplace inverse of fs is equal to Laplace inverse of 1 upon s plus 2 bracket square and Laplace inverse of gs is equal to Laplace inverse of 1 upon s minus 2. Therefore, Laplace inverse of fs is equal to using first translation property of inverse Laplace transform. Inverse Laplace transform of 1 upon a square plus 2 bracket square. Here e raised to minus 2t Laplace inverse of 1 upon a square is equal to e raised to minus 2t Laplace inverse of 1 upon a square is t. that is function of t. Laplace inverse of gs is equal to Laplace inverse of 1 upon s minus 2t, that is e raised to 2t, that is dt. Therefore, by convolution theorem, Laplace inverse of Fs into gs is equal to 0 to t f of u g of t minus u du is equal to 0 to t here ft is e raised to minus 2t into t, e raised to minus 2u into u, g of t minus u e raised to 2 t minus u du is equal to 0 to t e raised to minus 2u into u e raised to 2t into e raised to minus 2u du is equal to, here e raised to 2t is constant with respect to u, take outside the integration e raised to 2t 0 to t e raised to minus 2u e raised to minus 2u, that is e raised to minus 4u into u du. Using by parts, e raised to u into e raised to minus 4u upon u, integration of this e raised to minus 4u upon minus 4 minus integration of derivative of u is 1, integration of e raised to minus 4 is minus e raised to minus 4u upon minus 4 from 0 to t is equal to e raised to 2t u e raised to minus 4u upon 4 minus minus plus 1 upon 4 e raised to minus 4u 0 du 0 to t is equal to e raised to 2t u e raised to minus 4u upon 4 plus 1 upon 4 integration of e raised to minus 4u e raised to minus 4u upon minus 4 0 to t is equal to e raised to 2t u e raised to minus 4u upon 4 plus e raised to minus 4u upon, here minus sign, upon 16 0 to t e raised to 2t t e raised to minus 4t upon 4 minus e raised to minus 4t upon 16. Here for the lower limit, here 0, this terms vanishes, minus minus becomes plus, e raised to 0 is 1 by 16 is equal to t e raised to 2t into e raised to minus 4t, that is e raised to minus 2t upon 4 minus e raised to minus 2t upon 16 plus e raised to 2t upon 16. show that the show that one star one star one star star one n times t raised to n minus 1 upon n minus 1 factorial, where n goes from 1 2 3. Solution. By convolution theorem, f star g is equal to 0 to t fu g of t minus u du. Let ft is equal to 1 and gt is equal to 1. Therefore, naturally gtu minus 1 is equal to 1. Therefore, 1 star 1 is equal to 0 to t 1 into 1 dt is equal to t, du is equal to integration of du is u, 0 to t is equal to u, 0 t minus 0, that is t only. Again, 1 star 1 star 1 is equal to t star 1 is equal to 0 to t u into 1 du is equal to u square by 2, 0 to t is equal to t square by 2. For lower limit it becomes 0. That is 1 star 1 star 1 is equal to t square by 2 factorial. Continuing in this way, we get we get 1 star 1 star 1 star dash 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 star 1 n times. Therefore, here 1 star 3 times, therefore t square by 2 factorial. Here n times means t raised to n minus 1 upon n minus 1 factorial. Okay, we stop here.